Right, there we go, everybody. Well, good morning, good afternoon, depending on where you're joining us from. My name is Jesse, and I am your virtual adventure guide here at Exploring by the Seat of Your Pants. And welcome back. I know for many of you, it's your first program joining us again since March break. It, I hope, was a wonderful, relaxing time for you all. But welcome back as we continue to showcase and celebrate the coolest in science and exploration around the globe. For our YouTube friends, I did just note to our people here on StreamYard, we do have our daily dive playlist now on our YouTube channel. If you want to check that out, see it in our latest newsletter, and going forward, some really, really cool stories to explore there as well. But for today's program, we are continuing our epic series with Fisheries and Oceans Canada, featuring one of my favorite scientists we've had on from there over the last few years, and that is Hilary Moors-Murphy. So she is going to dive in today with her amazing work, listening in on the amazing creatures off Canada's east coast and beyond. She is at the Bedford Institute of Oceanography, right nearby where I am, really in the scheme of things, here in Corner Brook, Newfoundland, just down the coast in Nova Scotia. So I'm really excited to hear from her. We're going to listen in. We're going to hear some really cool stuff. And then I can't wait for all your questions about the incredible marine mammals that we have on our coast. So without further ado, Hilary, thank you so much for joining us again, and welcome back to the broadcast.
Thanks so much, and hi to everyone. I'm really excited to be here today. I'm gonna just share my screen here because I have some slides and some sounds I want to play for you. So bear with me one moment.
Oh yeah, while you're doing that, I'll just note too, for our YouTube classes, if you guys want to let us know where you're joining from, we'd love to hear from you guys, get a sense, and you're able to share all your questions there as well, of course. Hilary, it looks like we've got it up and it looks good to go. Let's do this thing.
Awesome. Excellent. Well, thank you so much for having me and hosting me today. As Jesse said, my name is Hilary Moors-Murphy, and I'm a research scientist with Fisheries and Oceans Canada. And I'm here to talk to you about something very near and dear to my heart, and that's my research, which mainly involves listening to whales. So I work at a place called the Bedford Institute of Oceanography, or BIO for short, and this is a really cool place to work. It is Canada's largest oceanographic institute, and there's lots of really neat research going on here about whales and lots of other aspects of the ocean. And we're located off the east coast of Canada in Dartmouth, Nova Scotia. And I'm here to tell you a little bit about me. So I am a marine biologist, and more specifically, a whale biologist. And I've been studying whales for a long time now, over 15 years studying whales off of Eastern Canada. And my main area of expertise is actually not so much looking at whales, but listening to whales. So I'm also what's known as an acoustician. And that's basically just a fancy way of saying that I listen to sounds. And I spend a lot of time listening to underwater sounds and the sounds that marine mammals like whales, dolphins, porpoises, and even seals make. So my research program is to help us better understand how whales are using our waters off Eastern Canada throughout the year, mainly using passive acoustic monitoring. And I also call that PAM. That's a short way of saying passive acoustic monitoring. And what does that mean? Well, that basically means listening in and studying sounds. So how does that all work when it comes to whales? Well, water is a really good conductor of sound. And that basically means that sound can travel very fast and much farther underwater than it can in air. And whales, dolphins, and porpoises have taken advantage of this by evolving acoustic communication systems that are really adapted, highly adapted to sending out and receiving underwater acoustic or sound signals. And they use sound for just about everything they do. socializing, breeding, rearing their young, foraging, navigating, and more. And many whales are very highly vocal. They produce underwater sounds just about everywhere they go and associate it with everything they do. And what's really cool is that many species produce distinctive underwater sounds. And that means that we can identify a species that's in an area just by listening to the sounds that are occurring there. So as an example, just to give you a couple of examples of this, blue whales. Blue whales are the largest animal on Earth, even larger than the largest dinosaurs. And they produce these really, really low frequency moans that are very loud and can travel really far underwater. Blue whale low frequency calls have been recorded across entire ocean basins. So I'm going to play an example of those, and you have to listen very carefully because they're very low in frequency, so they'll sound a little bit like a rumble. So just a quick check there, Jesse. Were you guys able to hear those blue whale moans?
We sure were. That was spectacular. Thanks, Hilary, for checking.
Excellent. Okay, so that's a low frequency blue whale moan, and that's very different than the next sound that I'm going to play for you folks. And I'm going to play some common dolphin clicks and whistles. So common dolphins, they're much smaller than blue whales, and they tend to make higher frequency sounds or higher pitch sounds, like those snapping sounds that you heard and the squeaky sounds. Those are clicks and whistles. So hopefully already you're getting a feel for how we're able to tell different species apart by the sounds that we're hearing. So those blue whale moans are very different than the clicks and the whistles of the dolphins I just played. So we can actually learn a lot about when and where different whale species are occurring, and even potentially what they're doing just by listening for their sounds. And that's where my research program comes in. So it all starts with collecting underwater sound data or acoustic data. And I do this by deploying underwater instruments. These are these big instruments you see here. And they are actually underwater hydrophones. And we take these out to an area we're interested in monitoring, and we lower them over the side of the vessel. And then we release the instrument, and there's a big heavy weight at the bottom of them. In this case, a big heavy iron training wheel, and that makes the whole system sink to the bottom of the ocean. You can see it going down right now in my video here. So that's my hydrophone. It's going down, it's sinking to the bottom of the ocean, and it will actually stay out there. We've been leaving these systems out for up to a year or even a little over a year at a time. And while this system's out there, it's continuously recording underwater sounds. And that includes recording anything that's out there making a sound, like whales and dolphins and porpoises. We get fish sounds, we hear seals on our recordings. We even hear what humans are doing, so we can hear when vessels come into an area or other activities that are going on. And we've been deploying these instruments for many years now, over a decade, and have been able to collect thousands and thousands of days of recording at many different spots off of Nova Scotia. So these circles on this map, they just represent different areas that we've been putting these acoustic systems out at and collecting data, sometimes for years and years at a time. So we have lots of recordings to go through, and we listen to those recordings and we identify the different whale sounds that occur on them. And that tells us something about the different whale species that are using these different areas. So for the rest of this talk, I'm going to play for you some of the examples of different types of whale sounds that we hear on our recordings off of Nova Scotia here. So the first example I'm going to play for you is one of my favorites. It's one of the most iconic whale sounds that are out there, and that's the humpback whale songs. And we do hear humpback whales singing off of Nova Scotia. So here's some humpback whale songs that we've recorded. So these humpback whale songs are really kind of neat because off of Nova Scotia, it's thought that humpback whales mainly come up into our waters in the spring, summer, and fall to feed, and then they all migrate down south during the winter to breed and give birth to their young. However, we recorded these whale songs in the middle of winter off of Nova Scotia, and that proves that at least some humpback whales are hanging around throughout the year. And you can hear these songs are full of very low frequency sounds, low pitch sounds, lots of moans and groans, and you hear the occasional chirps and higher frequency sounds. But they are one of my favorite whale sounds. We also hear another species of baleen whale called a minky whale. And in this case, I'm going to play for you some minky whale pulse trains. And these sounds are really interesting to me. They sound a little bit like a heartbeat. So I'm going to play these minky whale pulses for you. So that minky whale pulse train is called a slow down pulse train. And that's because as the train goes on, the spaces between the pulses get a little bit longer. So hopefully you heard those pulses. Another species that we spend quite a bit of time studying here off of Eastern Canada is the highly endangered North Atlantic right whale. And right whales make a very interesting call called an up call. And it's called an up call because it starts low and then it goes up. And I'll play an example for you in a minute here. But these up calls are what are known as contact calls. And all of the whales in the population will make these up calls. So that means the young whales as well as older whales, males and females. And it's thought that these calls are meant to help the animals stay in contact with one another, even when they can't see each other underwater. These up calls indicate that they're close by. So here's a North Atlantic right whale up calls. So this is the main call that we're monitoring for when we're trying to figure out if a North Atlantic right whale is in an area. We have other dolphin species off of Nova Scotia, including the Atlantic white-sided dolphin. And dolphins, most of the sounds they make are whistles, clicks, and buzzes. So here's some example of Atlantic white-sided dolphin: whistles, clicks, and buzzes. There's other whale species that produce underwater clicks. So what I'll play for you now is an example of sperm whale echolocation clicks. And these echolocation clicks, what they are a sperm whale that's underwater hunting for its food. So it produces these clicks, and when the clicks hit an object in the water, an echo bounces off that object. And using these clicks, sperm whales can figure out where their prey is underwater. And they do this because under the water is very dark. They can't actually see their prey. So using echolocation clicks allows them to find their prey, even though they can't see them. Sort of like how a bat echolocates at nighttime. So here's some sperm whale clicks. And you can hear those are a little bit different than the dolphin clicks I just played because they're a little bit lower in frequency, so not as high pitched as the dolphin clicks. There's another example of a toothed whale echolocation click, in this case, northern bottlenose whales. So northern bottlenose whales are a type of beaked whale. They are not dolphins, even though they look like dolphins. These whales can grow to be 6 to 10 meters in length, so really big animals. And they're found really far offshore in deep water, often more than 500 meters deep. These whales will dive to depths of over 1,000 meters deep for more than an hour at a time. And while they're diving, they produce these echolocation clicks as they hunt for their primary prey, which is a deep water squid. So here are some northern bottlenose whale echolocation clicks, and these are a little bit higher pitched than the sperm whale clicks, so you'll have to listen carefully. So that snapping sound that you heard, that was a northern bottlenose whale hunting for its food. And of course, on our recordings, we hear a lot of things that we haven't been able to identify yet. And some of the sounds we hear are very interesting, but we can't always figure out what's making them. So I'm going to play a mystery sound here. I don't know actually what's making it, but I've recorded it in a deep water site off of Nova Scotia. So here are some interesting sounds that we don't quite know what's making them. So hopefully today you've gotten the message that our oceans are full of sound, and studying these underwater sounds is helping us to better understand our marine ecosystems and the whales that live there. And with that, I just want to say thank you, and I'm happy to answer any questions.
Fantastic. And by the way, I love the Team Whale logo. That was whoever designed that did a very nice job. I find it so interesting having grown up where a lot of the people that I was inspired by were inspired in turn by Jacques Cousteau, whose most famous thing was the idea of the silent world being the ocean. And every time we have on marine biologists, it's anything but. Like, it's one of the loudest, most fascinating places where there's so much to discover acoustically. And it's always such a treat to get to hear some of the amazing creatures that are there. So thank you for the whistle stop tour, as it were, of some of these amazing things. We've got 4 classes with us live. We've got a bunch joining us on YouTube. I'm actually going to start with a YouTube YouTube question and give our live classes a second to think about it and percolate with their questions. So Miss Williams' student wants to know, is it true that if you're underwater, you're swimming, you're near a whale, and it calls beside you, can your ears be injured by that? Like, how powerful are these calls? Enough to cause deafness, problems, anything you can share?
Oh, what a great question. So some of these whale sounds can be very loud. And for example, in the case of a sperm whale click, it is one of the loudest sound generating organs underwater that exist. And some folks equate it to when a sperm whale produces a click. If you're really, really close by, it would almost be like hearing a gunshot. It's so loud. So some of these sounds, they are loud enough that they could cause temporary hearing threshold shifts. Certainly they're really loud. In the case of the blue whale, where I was saying it's really loud and it can travel across entire ocean basins, although it's really loud, it's actually lower than the human hearing range, and we don't hear them really well, although a lot of other animals would hear them.
Yeah, I always like hearing about infrasound or ultrasound because it's so weird to think about as people. I mean, we have this with vision as well, but the idea that there are sounds that are outside of our hearing range, something like a bat, a certain cetacean certainly, and then you have the things that are like below our range of hearing, which interestingly, people tend to feel in different ways too. A lot of the sites on land that have like a spooky vibe associated with them, they find out that they're just full of infrasound, which just affects you in sort of an odd way. So I always love hearing about these things like this. And great question. I was looking up sperm whale sound, by the way. You get up to 200 decibels, which is more than a gunshot. It's more than a jet engine at close range. Like, it's incredibly powerful sound.
Yes.
Great question. Thanks, Miss Williams. They're in London, Ontario, by the way, and we are going to head to Miss Finn's class joining us in Freehold, New Jersey, one of my favorite places ever, because I think we've gotten every school in Freehold over the last few years. There's none left, and so it's nice to have fourth graders. Hi, come on mute. I want to hear you talk. It's way more fun that way. Come run and press the unmute button, and then we'll take a question. Here we go. Oh. Come on up. Yeah. Oh, don't trip. But unmute. You got to unmute, guys. Yeah, perfect. Take your time. All our classes, Miss Webb's class, you guys can unmute too. Everyone can unmute in the background, I promise.
Okay, got it. All right, go ahead, Jay.
Can other animals hear these calls?
So is it just us that can listen in, or other animals in the ocean, Hilary?
Absolutely, other animals can hear a lot of these calls. So any species in the ocean, they'll have their own sort of hearing range of sounds they can hear. Whales, they make a really wide range of sounds, whether it's the blue whale who makes really low frequency sounds, or dolphins and porpoises make really high frequency sounds. And depending what your hearing range is, you might hear all of those sounds or maybe just some of the species underwater. And it's really interesting, Jesse, you bring up sort of this idea, infrasonic sounds and ultrasonic sounds.
Yeah.
So basically, the term sonic refers to the human hearing range. So something's in the sonic range, it means humans can hear it. And that's roughly between 20 hertz and 20 kilohertz. But there's a lot of sounds out there that whales and dolphins are making that are much lower than that or much higher than that. So when I study whale sounds, I know I said I spend a lot of time listening to sounds, but I actually spend a lot of time, I like to say, looking at sounds. And you saw a picture in my slides of, it was a picture of sounds and how I can look at them, because some of the sounds we get, I can't actually hear. But certainly there are lots of other animals that can hear these sounds, and lots of other animals in the ocean that produce sounds. So did you know fish produce sounds? There's snapping shrimp out there that produce sounds. Like, so many other things produce sounds, and certainly whales can hear those things as well.
I'm really glad you mentioned the fact that you get to interpret and try and find ways of hearing things that we otherwise wouldn't be able to hear. So much of science is extending the reach of our senses. And we've done some astronomy programs recently where, we look at the James Webb Space Telescope, it's seeing an infrared. We don't see an infrared, but the telescope does. And we find a way to interpret that in a way that we can understand. And it's very similar with the soundscapes that you're getting the chance to listen in on. Very, very cool.
One of the really cool things about that is in recent years with technology development, developments, we're able to record sounds at much higher frequency than we ever were. And because we can record higher frequency sounds, we're actually discovering like new species that are using our waters that we didn't know were ever using them because we couldn't hear them before. So it's really neat what technology can do.
It's one of my favorite things in all of biology. So like as a biologist by background, you know, I think we all assume you have to either see something to identify it, or basically that's what you have to do. And so many of the scientists we bring on this broadcast, whether it's the sounds or their DNA left in the water, we had a scientist who came on and talked about finding leeches that had like eaten from the animals in the forest. And so you got a sense of what the forest was from what the leeches had eaten. They're like fantastic. So I love things like this. So thank you, Hilary. Speaking of London, we had our first group in London. We'll go back to this lovely city, Miss Hurley's class. If you guys want to come on in and take us away, you're good to go.
How do you identify what like sound of each animal, like whale is?
How can you tell, Hilary? Let's watch.
So what I can do is, for a lot of species, I can tell the species apart, but I don't know how to tell like individual whales apart. So if there was, you know, two different blue whales calling, to me, they kind of sound the same. But I'm sure the whales can probably do it, but we haven't figured out how to identify specific individuals for most of the species. There are a few species that do make sounds that are really specific to individuals. And an example of that is bottlenose dolphins. Bottlenose dolphins make certain types of whistles that are called signature whistles. And an individual will have like one signature whistle that's unique to them. And so you can tell bottlenose dolphins apart by the certain types of whistles you're hearing within an area. Another example of that would be killer whales. Certain killer whales, groups of killer whales, they make certain types of calls that are unique to that group. But for most of these species, I can tell if it's like a blue whale or if it's a common dolphin or if it's a sperm whale. But I can't tell if you know, individuals within a species apart.
But the species sound very differently.
Maybe in the future.
Maybe in the future. Well, I've always liked the idea that, you know, we spend so much time now trying to sort of listen in for potential like alien intelligence. And it's like we have intense intelligence right here on Earth. And if we spent more time and more resources trying to understand some of the things that they were saying, we learn so much. And it's such a fascinating field. By the way, in my high school, I was the only guy who walked around whistling. So I had a signature whistle as well. Everyone knew it was me coming around corners. Miss Webb's class, we are going to head back to the U.S. In Bartonville, Illinois. If you guys want to come on in, unmute your mic. You're good to go. Hey guys.
Can other animals understand the whale sounds?
Ooh, the interpretation question.
That's a really tough question to answer. So even as humans, we understand some things about the sounds that the whales are making, but not everything. So you know, a lot of people commonly ask me like, do you know what the whales are saying? And I would say, well, if it's a sperm whale making echolocation clicks, I think that what they're saying is that they're hunting. So there's some sort of general behaviors we can associate with certain types of sounds, but for the most part, we don't, you know, specifically know what the whales are saying. And I suspect that a lot of the other animals that are listening in on the whales also might not know specifically what they're saying. But in terms of like, you know, like whales clicking, so they have found that killer whales on the West Coast, certain types of killer whales, they don't actually echolocate on their prey because the prey have learned that if they hear that click, they should go hide because it means a whale is hunting for them. So they've had to develop other strategies to find their prey underwater. So in some cases, some of the animals might know like, that means trouble. Maybe I should get out of an area. But for the most part, I think we're
at the early stages.
Got a lot to learn about how to interpret whale calls.
I'll follow up with two quick anecdotes recently in science about this that are really cool. So we've discovered that great white sharks off the California coast all like hide around a certain island there when the orcas are coming. So they like very distinctly know that the orcas are coming, and all these apex predators, everyone's scared of great white sharks, are terrified of the orcas and will get out of Dodge as soon as possible. In the animal kingdom, generally, we do have animals on land, certainly, that can understand the nuances of each other's communications. You'll find this with monkeys and various things where they'll call, there's birds that sort of act as sentinels for monkeys and other creatures, and they'll call differently if it's like a leopard or an eagle that's coming, and the animals will act accordingly. So you have interspecies communication in that way. That's very concrete. The calls sound very different, but I would expect with whale intelligence, as we continue to explore more in that we will certainly find, you know, the more the merrier, right? Like, it's a very exciting field of study. Mr. Shattuck's class, we're going to head to Chalk River. YouTubers, don't be shy. We'd love to take more questions from you. And then we'll do a whole other round because, Hilary, you are like whipping through this Q&A. This is amazing. Mr. Shattuck, come on in. Hey, guys, welcome back.
Are the species of whales limited to their calls, or can they mimic others as well?
Ooh, good question. Are there any mimic whales, Hilary? Huh.
I'm not aware of any examples of species mimicking each other. Although a lot of species, they will produce similar calls. So there's some calls that you're like, that's definitely a right whale, or that's definitely a fin whale. But a lot of species, their calls will actually overlap and they'll make sounds similar to one another. And this actually creates a problem for us because, so for example, the baleen whales, almost all the species produce some form of what's known as a down sweep. So it starts high and it goes low and it's in the same frequency range. And when I hear those, I'm like, I don't know if that's a blue whale down sweep or sei whale down sweep or a fin whale down sweep. So they certainly can make sounds that are similar to one another. And yeah, we're looking for the cases where there's like, unique sounds that are specific to one species to help us tell them apart.
I love that question, though. Like, what a unique, thoughtful question. Way to go, guys. Certainly, again, animal kingdom more broadly, lots of things mimic each other's sound. The best example on Earth is something called the lyre bird, L-Y-R-E bird.
Mm-hmm.
Look that up when you're done the program. It'll blow your mind. St. Dunstan, you guys joined in a little late, but if you want to unmute your mic, I'm happy to come to you guys for a question. Just let me know if you'd like to take a question while we're here. There we are. Hi, guys. Welcome in. Hi, unmute. I want to hear you scream and yell. Hi.
Hi. Sorry we're late. We had internet problems, so we missed the first part, but thank you so much. We're so excited to meet you.
So excited to meet you guys too. And if you do think of any whale questions of any kind, what I'll do is I'll come back to you and you can ask anything you'd like, okay?
Okay, thank you.
Awesome, thank you. Nice to meet you all. Ms. Finn's class, we're going to head back to you guys. Very fitting name for a whale class, by the way. Hey, Doris, come on in. Hi,
Hello, David. Be respectful. Go ahead, Emery.
So how do whales make sounds, and where do the sounds come from?
Nice.
So it kind of depends on the species. When it comes to toothed whales, like dolphins and porpoises and other toothed whales, they actually produce the sound in their forehead. So they have a sound producing apparatus there. And basically they're these little lips inside their head that sort of open and close, and it makes it helps break up the air as it moves in the spaces in the head, and then they project that sound out through their forehead. So when you hear a dolphin clicking, it's not actually clicking out of its mouth like you and me. So you can imagine they're underwater, and if they're opening their mouth all the time, there's going to be water getting in that. So it doesn't work that way. What they actually do is they make a sound in their forehead and they project that sound at the front of their forehead. So that's how it works for odontocetes. We actually know a lot less about how sounds are produced in the baleen whales, the mysticetes. And it appears that the sound is being generated more so in the throat and resonating out through the throat of the animal. Although they don't really have like vocal cords or phonic lips like the odontocetes or like you and I. But it is interesting because they're not producing sound in their mouth and they're not projecting it out of their mouth. It's more through the forehead in the dolphins and through the throats of the baleen whales.
So I like that you've been able to translate some of the science so beautifully into something that students of very wide ranges understand. But phonic lips of the odontocetes is the nerdiest possible title we could have used for this. in that answer. Miss Hurley's class, I'm going to head to you. YouTubers, don't be shy. I will take a few more questions from you, but we do have 4 more live classes, so lots of time. Miss Hurley, come on in. 867.
What's your favorite whale call?
Yes, favorite whale call. We always get a question like this, and I love it every time. No pressure.
I was saying earlier in my presentation, I do love the humpback whale songs because they are so iconic. And what's I think is really cool about the humpback whale songs is that's really what turned the tide for whales. Like back in the olden days, a lot of people were hunting whales, and people started to record their sounds and realized humpback whales were making these really beautiful songs. And when they start to play those recordings for other people, people start to care about whales a lot more because of those humpback whale songs. So I think the humpback whale songs are really cool and really neat and interesting to study. Those songs, they change constantly, and they change over time. They're different between ocean basins, and people have been studying them for decades, and we still have like so much to learn about why humpback whales are even making those songs, or why they're changing them, and how it all works into their system. So I think those would be my favorite.
They are pretty cool. My all-time dream of an animal interaction would be to be in the water for the humpbacks when they're upright and they're singing. Like, that is just the most wild thing that you can experience on this planet. And truly, I'm so glad you mentioned the environmental thing. I mean, there are really 3 things that like led to the 60s, 70s environmental movement. We have Silent Spring by Rachel Carson. We have The View of the Earth from the Moon, where we're going around and we're like, wow, that's a planet. We live on that. And there's Whale Song. Like, that was such a huge integral part of Clean Air Act, Clean Water Act, Endangered Species Act, like all these things that we now sort of take for granted almost as ways of protecting wildlife, ecosystem, species, and more, in part came about from the recognition that whales have this incredible ability to communicate and intelligence. So what a cool field of study, and I'm so glad we highlighted
Yeah, absolutely.
I'm going to head to YouTube for a second to Ms. Williams' class, and then we're going to go to Ms. Webb, Mr. Shattuck, and St. Dunstan. If you guys have a question, let it percolate, and you got a few more minutes to think about it. But Ms. Williams' class wants to know, a bit of a nuance from one of our earlier ones. Can species use calls to trick other species? And what made you choose this area of study?
Ooh, can species use calls to trick other species? I'm not aware of any specific examples in whales, but I think it's a really interesting question. And now you got me thinking, do they do that? In terms of what got me into this, I always, like when I was really little, I decided I wanted to be a whale biologist. And when I went to university, I was doing a Bachelor of Science, and a fellow at the university where I was studying, he studied seal sounds, and I started working in his lab. And I realized as I started studying seal sounds with him that I really liked underwater sound. And I kind of stuck with it. And what I think is really neat is like I was doing studies on seal sounds back in 2000, around 2001, 2002. And even in just like the past 20 years, like the technology around how we record sounds, what we can learn from them, the discovery of like new sounds people are making or whales are making as technology has gotten better has changed a lot. And so how I used to study sounds back in the early 2000s versus how I do it now has completely changed. And I just find the whole technology development side of it and what we're learning by studying whale sound is really, really exciting. But yeah, that's how I got into it. I started off studying seal sounds. I was studying harp seal sounds up in the Gulf of St. Lawrence.
Cool. Thanks, guys. What a great question, Ms. Williams. Ms. Webb, we're going to head back to Illinois. Come on in and unmute your mic. Take us away. Hi. Hi there.
Can you tell gotta get close. Can you tell the difference between a baby dolphin and a whale and an adult whale to a baby whale?
Great question. Thanks.
Ooh, I do like that. And you know what? In some cases, we definitely can, and we have examples of that. So the younger whales, the baby whales, we actually call them calves. And the calves, when they're very young, they're just sort of learning about how to make sounds. And a lot of the times, the sounds they make, they're trying to imitate their mums, but the sounds they make are quieter than what the adults make, or maybe they're shorter than what the adults make. So there's definitely lots of examples of young whales learning to make the sounds that their mums make and that their other group around them make, and you can tell the younger whales apart by the sounds that you're hearing.
Yeah, fantastic. Thanks, Miss Webb student. All right. Folks, time flies and you're having fun. We're at the 41-minute mark, so we're going to take 2 more questions to wrap up. St. Dunstan, think about it for a second. You can unmute your mic in a sec. Actually, I can head to you guys first. Have you got one? Perfect.
Yeah.
Come on in. Hey, guys.
How do we take care how do you take care of whales?
Yes. How do we take care of the whales? I love it.
Wow, that's a big question. Well, how do I take care of whales? I think I do it by learning as much as I can about them, and then being excited about them and telling people about why they're so cool and why they should care about the whales. There's lots of different ways to take care of whales, and lots of different things that impact them in our ocean. And I think the more we're aware of what whales are out there and when they're there and how long they're there for, the better we can protect them from different activities that are going on in the ocean.
It's always my favorite question, Hilary, is every time students want to know how they take care of things. I think everyone assumed it would be my generation that would be like the gung-ho, know the facts, take care of everything, and it's not. It's like all you kids in the classes today. It's just amazing, your level of knowledge, interest, understanding. I think the one thing that we sort of come to in every one of these programs is the idea of don't waste, whether it's plastics, whether it's food, whether it's emissions. Go through life recognizing the value of what you have, what you're able to have, and don't squander it. Don't just throw it away for nothing. And if you do that, you'll help protect not just whales, but pretty much every creature and ecosystem on this planet. So St. Dunstan, great question, guys.
And another, when it comes to whales, another thing that has a big impact on them is underwater noise.
Yes.
And so, one of the things that makes a lot of noise in the ocean is shipping activities. So things that are coming from across seas, they have to come in ships, and those ships make a lot of noise. So one of the ways you can help protect whales is exactly what you're doing is don't waste. When you go out and you buy something, instead of throwing that new pair of sneakers out after a year, maybe you could keep them for a year and a half or 2 years so that you don't have to buy as many, and then we don't have to ship as much stuff across the oceans. Those are all really great ways to protect not just whales, but everything in the oceans.
Since I was a small boy, I've had a grand total of 4 backpacks, all of which I leave to the point where they start growing sentient life inside them and like eyeballs start developing randomly on the ocean. I'm like, okay, time to go to the garbage. But that saved me a lot of money and has been really as a good conversation starter too. So there you go.
Yeah, you could say you're doing it for the whales.
That's right, for the whales. I have the sketchy bag. I tell my wife that all the time. Mr. Shatter's class, we're going to head back to Chalk River for one final question. This has been so much fun. I really do encourage you to check out more of Hilary's work on our YouTube channel, online, the entire Fisheries and Oceans series. Everything we do is on YouTube, so you can check that out when you're done. And of course, the Bedford Institute of Oceanography as well. Now, Mr. Shatter's class, Carter specifically, nice to see you again, man. Come on in for a final question. Hey.
What is the longest and oldest whale?
The longest and oldest whale, Hilary.
Well, the longest whale, so the biggest whale would be blue whales. Blue whales grow to be 30 meters in length. They are huge. They are bigger than like even a brontosaurus. So the longest thing that ever lived on Earth. The oldest whales, I'd have to go check my facts on that one. I think bowhead whales and some North Atlantic right whales were documented to live over 100 years. So whales can be very long-lived. Over
211. I know that we've got to 211, which is not the oldest animal, but it's the oldest whale. So like they're incredible. Blue whales, we know 80. Like whales and people are like the longest lived mammals on this planet, which is so cool. So I'm so glad we got that question. We could talk all day long, and I wish we could, but unfortunately, kids have to go to another period soon. So is there a final message you want to leave with all our classes today before we bring them in for a big thank you and farewell about the work that you do, about whales, anything you want to wrap us up with before we say goodbye?
Underwater sounds are amazing. I encourage you to go out and learn more about them. There's this really cool website called Discovery of Sound in the Sea. So if you like this talk about underwater sounds, you'd like listening to different whale sounds, if you go to Discovery of Sound in the Sea or DOSITS, you will learn lots more about whale sounds. You'll get to play lots of different whale sounds. Yeah, and I just hope you really enjoyed this talk, and I inspire you to go out and listen to the world around you.
Amazing. By the way, you're the first person to ever mention that site ever. I just brought it up. I put it in our YouTube chat too. I'll put it in our StreamYard chat for everybody so you guys can have that. But what a cool resource. And I really do encourage you to check it, everybody. Hilary, what fun. As you know how we wrap up every broadcast, I'm going to bring in Miss Finn's class, Miss Hurley, Miss Webb, Mr. Shattuck, St. Dunstan. You guys want to unmute your mics and join me in saying a big thank you and farewell to Hilary for joining us today. You are all now in the broadcast. Thanks, everybody.